Standard 10, some most important example for board exam we have to solve today. First example, root x, root 2 x square plus 7x plus 5 root 2 equal to 0. Quadratic equation is given. We have to find roots of the given quadratic equation by factorization method. First, root 2 and 5 root 2. We have to multiply 5 into 2, 10. We have to split according to middle term, 7x, 5 to the 10, 5 plus 2 plus, hence we have to write root 2x square 7x 5x plus 2x plus 5 root 2 equal to 0. Then we have to take common from two terms, first two terms, root 2 x square plus 5x plus 2x, that means root 2 into root 2 x plus 5 root 2 equal to 0. 2, that means root 2 times. Take common from this, only x is common, root 2x inside the bracket plus 5, x is outside the bracket, common terms, plus now root 2 is common, inside the bracket root 2x and plus 5 equal to 0. This bracket is common and hence root 2x plus 5 in second bracket x plus root 2 equal to 0. Therefore root 2x plus 5 equal to 0 or x plus root 2 equal to 0. Root 2 x is equal to minus 5 and therefore x is equal to minus 5 upon root 2 or x is equal to minus root 2. Hence there are two roots. One root is minus 5 upon root 2 and second root is minus root 2. Now another example, find the discriminant of the quadratic equation. Find the discriminant of the quadratic equation. Equation is given 2x square minus 6x plus 3 equal to 0. Given quadratic equation, we have to find discriminant and hence find the nature of its roots. Hence we have to find nature of its root. First we compare standard quadratic equation. We compare with standard quadratic equation. A equal to 2, b equal to minus 6 and c equal to 3. Then discriminant d is equal to b square minus 4ac is equal to b square minus 6 whole square minus 4a 2 c 3 minus 6 square 36 3 to the 6 4 the 24 12. Hence first answer is discriminant d equal to 12. Then second, hence find the nature of its roots. We have to discuss about the nature of its roots. There are three possibilities. If d is greater than 0, if d is greater than 0, then roots are real and distinct. Hence two different roots. If d is equal to 0, then roots are real and equal. And if d is less than 0, then there is no real roots. Observing d, 12 is greater than 0. Hence we can say roots of the given quadratic equation are real and distinct. Now we see one important sum called AP, chapter number 5. Third term is 5. Third term is 5. A3 is 5. And seventh term is 9. Seventh term is 9. Our question is determine the AP. Determine the AP. If given data is A3, third term is 5 and seventh term is 9. We have to find AP. Determine the AP. Determine the AP. We have to find first A, first term, then common difference. Using formula an is equal to a plus n minus 1 into t. Given data A3 is equal to a plus 3 minus 1 into t. A3 is given 5. A plus 2t. Number 1. Similarly, A7. A plus n is 7 minus 1 into t. A plus 6t. A7 is given 9. Number 2. Now, first equation first is 5 equal to a plus 2d. By elimination method, minus a is cancelled. 6d minus 2d, 4d, 9 minus 5, 4, and hence 4 by 4 equal to d, 1 equal to d. D equal to 1. Then put the value of d in equation number 1. Put the value of d in equation number 1. Value of d is 1. 2 into 1. 5 is equal to a plus 2. 5 minus 2 is equal to a, and a equal to 3. Now we have to write required AP. AP, first term is A, AP is A plus D, A plus 2D, so on. This is the standard form of AP. A is 3, A plus D, 3 plus 1, 3 plus 1 is 4, 3 plus 2, 5, so on. So that is our answer. 3, 4, 5 is required AP. Find the mode of the data. Find the mode of the data. We have to find mode. Mode of the data. Given data is mode. There is question mark. Mode of the data. Given data is L equal to 3, H equal to 2, F07, F1 8, F2 2. F1 8, F2 is 2. This data is given and we have to find mode of the data. Using formula, mode is equal to F1 minus F0 upon 2F1 minus F0 minus F2 into H. Formula of mode, L is 3 plus F1. F1 is 8 minus F0 7 divided by 2 F1 is 8 minus F0 is 7 and F2 is 2 into H is also 2 is equal to 3 plus 8 minus 7 1 into 2 divided by 16 minus 7 minus 2 is equal to 3 plus 2 upon 16 minus 7 means 9 minus 2 7 2 by 7 is equal to 3 plus 2 by 7 0.0 to the so on, 0.28 so on, and our answer is 0.28 approximately 3.28, right? Once again, another example. Find the zeros of the polynomial x square minus 5 and verify the relationship between the zeros and coefficient. First, we have to find roots of the given quadratic equation. There are only two terms. Observing quadratic equation, we have to factorize using identity a square minus b square. 5, that means root 5 whole square, x minus root 5, x plus root 5 equal to 0, x minus root 5 equal to 0, or x plus root 5 equal to 0. X is equal to root 5 or x is equal to minus root 5. Hence, alpha is equal to minus root 5 and beta is equal to alpha is equal to plus root 5 and beta is equal to minus root 5. We have to verify using formula x square plus bx plus c equal to 0. Comparing with given equation a equal to 1, b term coefficient of x, term of x coefficient is not given here and hence it is 0, c is equal to minus 5. First of all, alpha plus beta means sum of the two roots is equal to, using formula, minus b upon a, minus b 0, and alpha plus beta is equal to 0. According to our answer, alpha plus beta is equal to root 5 plus minus root 5 cancel is equal to 0. Alpha plus beta is equal to 0. Alpha plus beta equal to 0. This is according to our formula and this is as per our calculation. Now alpha beta is equal to root 5 into minus root 5. Answer is minus 5. Answer is minus 5. According to formula, alpha beta is equal to c upon a. C is minus 5, a is 1 and is equal to minus 5. Both are equal, hence relation is verified with given coefficient. Once again, we repeat the given sum. X square minus 5 equal to 0. Observing it, there are only two terms, hence using formula of a square minus b square, x whole square minus 5, that means root 5 whole square equal to 0. A square minus b square, a minus b, a plus b, using identity x minus root 5, x plus root 5 equal to 0. If x minus root 5 equal to 0 or x plus root 5 equal to 0. If x minus root 5 equal to 0, then x equal to root 5 or x is equal to minus root 5. Hence first root is alpha and second root is beta. Now we have to verify the relation of the zeros and coefficient of the quadratic equation. Using standard quadratic equation ax square plus bx plus c equal to 0, we have to compare given quadratic equation x square minus 5 equal to 0. Comparing it, x a equal to 1, b equal to 0, c equal to minus 5. According to the alpha plus beta, that means sum of the two roots is equal to minus b upon a. B is 0, 0 upon a is 0. Similarly here, as per our answer calculation, alpha plus beta minus root 5 plus root 5 plus minus root 5. Root 5 is cancelled. 0, 0 and 0. Both are verified. Then alpha beta, product of two roots. Root 5 minus root 5 minus 5. Here alpha beta is equal to, according to the given formula, C upon A. C is equal to minus 5 and A is equal to 1 minus 5. Both are equal. Hence the relation is verified. Thank you.